Thank you very much. Although some of my friends call me Dr. Denton, I'm not a PhD, and I wanted to explain a little bit about Denton Plastics and how we got started. I came out of the wood products industry as well, and I felt that that was kind of a dead and dying industry back in the late 70s when interest rates went up and the price of lumber went down, and we had some large problems because I had a mill in Republic, Washington that would buy trees on the stump, and usually it's 3 to 4 years before you process everything. And it created a lot of problems for a small business. And so we let people like Weyerhaeuser run that industry for us. One of the things we found out about scrap, though, is that most of the larger corporations, whether it's steel or any other metal, they are not really active in the process of bringing in recyclables. So it's same thing happened in the plastic industry. I don't know if everybody recollects, but Union Carbide, Dow Chemical, everybody started recycling plastic because of the necessity. And it was a demand that from people like us that wanted to make sure that that product was getting recycled. I got involved in the 80s, and when we were recycling ours, we have it on a little different than what was said earlier. We make a drop-in replacement for virgin plastic. The difference is the color. That's why black's our favorite color. We put pigments in to make it. And we also found out that you had to have more than just the normal plastic that you put in. We upgraded it. We put additives in. We cross-blended. We made certain recipes depending on the type of product that you have. There's 3 different types of recycling: industrial, which is where we started; commercial, which is generators; and then, of course, you have the post-consumer household stuff. We started with the low-hanging fruit, which is the industrial plastic. We did lots of industrial plastic, and at that time, 35 to 40% of my market was export. The complexion has changed dramatically since the mid-'80s. Now, what's happened is that most of the manufacturers started recycling their own material in-house and putting it back in the product, which is the right thing to do. It saved them money, and it helped save the earth. With the price of oil and gas going up, that's also made it an economic decision that everybody would be happy to deal with because it lessened their costs. We worked with major corporations to get involved in, like McDonald's. We did the polystyrene foam wars back in the day. Then we also have been involved with several corporations that want us to go in and do some R&D work, but most of our R&D work is done on the fly. As you can see by the picture up here, the first picture, that's a pile of drip tape. And when we first went, this is what people would do. They'd have us come out and they'd say, geez, we got a bunch of plastic. What are you gonna, can you pay us for it? Well, we decided that, it's time to start educating some of the public. This is more materials that we have found that we bring in and remanufacture after we've taught them to sort properly and effectively. This was at the nursery. This would be at Fred Meyer. It has a lot of paper on it. It has staples on it. It has all those, but our machinery can successfully take care of that. We grind it. We melt it down, and we put it through an extruder, which has a 200 mesh minus screen that'll take dirt out. It'll take out non-ferrous metals and paper. Then we would go, and this is polyethylene pipe. Somebody would call us up, and normally they'd just let it lay in the field until it degraded or they put it in the dump. We started getting the word out that we're capable of doing that. We do this with a lot of people in here in Washington. I know the city of Tacoma and Olympia and several other municipalities have worked with us, and we teach them how to get it to a point where we can recycle it. We can't get these in with half garbage in them, or else it doesn't work for us. And so they took the time, and of course we pay them for this. These particular roll carts right there, we pay anywhere from 12 to 16 cents a pound picked up at your door. These are pizza trays. We found out that they're all made out of ABS plastic, which is what your telephone used to be made out of. Now it's made out of various types of raw materials that people have seen a lot of these. These happen to be berry flats that are, one of the things about the Great Northwest is that we have a lot of nursery and agricultural products. These are buckets that we've taught people to clean, turn upside down, and bring into us. More lugs and flats. Here's another, triple rinse drums. We take the drums, we blend that with 3 other polymers out of the same family, and make a lot of plastic to put back into black pipe. This happens to be some flats. These are a little bit dirtier, and what we do as a company, if you clean it or we clean it. If you clean it, you get paid for it. If we have to do it, you got to pay us to do it. Bumpers. We do lots of TPO, high-impact bumpers. There are a lot of refurbishing companies that take off the metal or redo it and send it back to a shop to be put back on your car. The ones that don't make the grade go in a dumpster, we get them. Overwrap for wood products, polypropylene woven materials. We taught them to bale them so we could haul them longer distances. We pretty much stay for materials that are coming in scrap form. When I say scrap, this would be scrap. We work within a 300-mile radius. We do bring in materials from farther, from Chicago, from North Carolina, places like that, return ocean-going containers, but mostly that's regrind that's already been processed once and fairly clean, ready to go into our process. There's a typical example. We're in a position now where we also are looking and getting additional equipment for manufacturing. This happens to be the PET plant that I built in 2010. We took all the PET bottles from the state of Oregon and a lot of the MRFs that we went to the MRFs and explained to them how to try to be as clean as you can and be as selective as you can with all the pickers to take out only the PET bottles. PET is an interesting case within itself. Most of our stuff, our partners were the OBRC, Oregon Beverage Recycling Co-op, and that we are deposit bottle bill state. And that material in itself was deemed the best recycled bale in the United States. But in that bale, it's 21% waste. Stuff that you get from a MRF could be anywhere from 40 to 60% waste. Thus, that's why China has quit taking the 3 through 7 bales, quit taking a lot of the stuff that's been developed at the MRFs because we're sending garbage overseas, and they were having to deal with it. In this particular picture, you can see the bale breaker that would feed the next phase, which is on the top. You have a metal separation, then you have a NFR infrared separation that'll separate by polymer type, then you have a color sortation, and it all goes various directions. It's the same thing that's we're working on now, which is in place in several countries in Europe, where you separate the polymers by type. And the way to do that is to work up and down the chain, work with the homeowners, work with the consumers, work with the manufacturers that designed for recyclability. In terms of the packaging, the waste stream, if you take polyethylene, polypropylene, and polystyrene, you've just about have about 90%, it's about 89.6% of all the raw materials that is used in packaging. PET is the only one that is really, it's been handled through the bottle, but if you take a PET clamshell, they don't get recycled, because when you grind a PET clamshell, it turns to dust. So there's a lot of problems that are inherent with that. This is the solution. The solution is to bring materials in that are identified and in streams. When I say streams, I mean the packaging stream of polypropylene, polyethylene, polystyrene that can be successfully recycled. A lot of companies have tried to do this. The problem has been end market. Everybody says, well, you know, the end market isn't there. I bring it in and I separate it, and what do I do with it? Well, our industry around here we've developed a large appetite in our business for taking and making a usable drop-in replacement for virgin, and developed a strong marketplace. If you have a black flower pot or a green flower pot, I would say that there's an 80% chance that it's made out of recycled plastic. It's a perfect industry for the things that we want to look into. We've been doing that with them, like I said, for a long time. The difference is, in the 80s, when I'd go to a customer and I'd give them a break on the resin price, they would say they'll buy all the resin we can manufacture, but don't tell anybody you're selling to us. Everybody we had that thing about virgin plastic only. And even though our product may be of better strength, have the same rigidity, it was that taboo. What's changed, as we all know, is that the pull-through demand has created a want and a need for recycled plastic. And that's why I'm happy to be here talking to people that have the same kind of ideas of the importance of recycling and saving our natural resources. You know, oil and gas is going to go away sometime, and if the plant bottle people, they say that they wanted to make that 100% bottle. Well, they can't make it 100%, they made it 30%. But there is bottles being made out of 100% recycled PET. Several bottle companies do that, and that's because you can make food grade. I haven't gone into the medical grade part yet, but the food grade, they have what are called letters of non-objection, LNO, so that they have got into that. The final thing that we've been involved with, and this is just more of our plant. You know, you have the big round tub is a dry cleaner where you put the regrind in there and it gets dried. This happens to be our washing tank. All the little individual black motors on top. There's 24 different chambers in there, and it circles around. It takes about 2 minutes for circling around, and then it goes from there into our drying, into our bagging, and now those are all perfectly clean flake in the white bags, and those are the raw material, the inputs in the back bag. The other thing that we've done in Oregon, which I think is a first-class operation, is working with all the hospitals. The Providence Hospital, Legacy, OHSU, Kaiser, we're recycling all their blue wrap, because what they've done is developed the spoken wheel where they bring in from all the hospitals to one central location all the plastic that we've identified, polypropylene, the trays, the blue wrap, the little cartridges that are all the same that they get lots and lots of. So we're doing about 200,000 pounds a month of hospital waste, none of the bad stuff, none of the blood stuff and stuff like that, but all the identifiable waste that comes out of there. And to me, that's the thing that's going to happen more and more with people like the people in this room and all the government agencies, is to get more involved with identifying the streams. And if it can't be done directly from a commercial standpoint, let's work together to do a better job of demanding what recyclability and having recycled content like they have in California. Thank you.
We're going to go ahead and take a couple questions for Dr. Denton. And while we invite our previous panelists for that second session to join us up at the front. Any questions? Right here in the back.
How do you ensure that you're not getting any contaminants or recycling or heavy metals or anything back in your metals? Because I know some of the recycled plastics that we get from other countries, we really don't have that assurance.
Well, we have a lab, and we check all incoming inputs, and we also, in the stages between, we also put that in the lab and make sure, and then the end product, we also do the same thing.
Is there a process for wood products and composites that were talked about in the previous to recycle?
We don't do that, but I know that it's on the drawing board for a lot of the people that are manufacturing, like Trex, to bring that material back. But hopefully they're supposed to be there for 10 or 20 years, right?
One more in the back.
What?
Dirty plastics.
The microphone right there.
Dirty plastics. You talked about making sure that your customers send you material that's clean enough or in good condition, but do you get dirty material, and how do you deal with it?
Yes, we do. We do get dirty material. We don't get, I mean, we don't take it from the consumer, the household, but like when you look at the pipe that I had laying out there, it's polyethylene pipe. It's got dirt on it, and it's got buried rocks and things like that. When it comes in, we stage it, and we try to get as much of the bad stuff off of there as we can. As it goes through the grinding process, then there's a shaker table that has magnets on it and also has a screen where the dirt falls through. And then at the end, we have an elutriation system which blows off some of the particles. Whatever we don't get in that particular area, when we put it through the extrusion process, the screen pack itself goes down to 200 mesh minus, which is very, very tight.
Are you able to take dirty flower pots then?
What?
Dirty flower pots? You know, I see a lot of.
Yeah, we do a lot of flower. We do a lot in the flower pot business. We have a sheet that we send out to all the nurseries that explain to them, you know, what we want. If you bring it to us clean, you get paid for it. If you don't, you pay us to take it.
I didn't understand one of your shots of the new facility. Are you taking 337 mixed
Well, that's the PET plant. That's an old facility, but we're not going to take. What we're going to do is we're working on developing a better mousetrap. The 3 through 7 is other, you know, and then when you go through the chain, you don't want people to give you PVC. It just is. It's a contaminant to all the other recyclables. So we're in a retraining process. But working with the MRFs is the right way to go to get the volume.